Some people say statisticians are sadistic, but I say they are just a bunch of standard deviants. Although you might think this lesson's a little sadistic, because we're going to be doing standard deviation for frequency tables. And first, let's take a quick look at weighted averages. As a teacher, I deal with something called weighted averages all the time. That's because different assignments have different levels of importance. And basically, my tests count more than my quizzes, and my quizzes count more than my daily work. This will also come in handy when we're looking at averages for frequency tables because the steps are pretty much the same, where the frequencies represent the weights. So to determine a weighted average, you multiply each value by its weight or its frequency, depending, and then you sum the products from the previous steps and divide by the total number of weights. As an example, let's say we have a student from an AP statistics course, and when I taught AP stats this last year, tests were weighted 50%, quizzes 35%, and daily work 15%. And that's how you're normally used to seeing weights, by the way, is as percentages. So Simon has the following scores in each category. He's got an 87 on his tests, 80 for his quizzes, and 95 for the daily work. What is Simon's current average in AP statistics? Well, we're going to go ahead and I'm just going to show you kind of like, it looks a lot like the mean formula in general or average formula. And I'm multiplying the weight. I personally prefer to work in decimal, but this will actually work with percents. But since percents don't work for everything, I stick to decimal. So 50% is 0.5. I'm going to multiply that by 87. 35% of 80, 15% of 95, and then add the weights down here. I end up with basically 85.75 points over a total weight of 1. So Simon's current average is pretty close to an 86. Now, I also teach in an engineering summer program for high school students. And there, the midterm has a weight of 2, daily work has a weight of 1, and the final has a weight of 1. So these are not listed as percentages. Now, I could convert them to percentages if I wanted to, but I can also work with them with these kinds of weights. So there's no law that they have to add up to 1 or that they have to add up to 100, as long as they're consistent with the weights they're supposed to have. So Alana has a midterm grade of 94 and a daily work grade of 100. Now, she hasn't taken the final yet. So what is her average before taking the final? Well, it's going to be 2 times the 94 and 1 times the 100. Now, in this instance, I'm not counting the final yet because that would obviously bring her grade down, and it's unfair to include it at the moment. So for her progress report, she's going to have the 188 points from the test, 100 from the daily work, add those two together, and she will have an average of 96. Now let's take a look at frequency tables. These work the same way. So I have the different slices, the numbers of slices, quantitative data here, and their frequencies, and which means I have a total of 36 samples here. So I had polled my math club kids for a pizza party, and I said, how many slices should I order for you? So 4 answered 1, 8 answered 2, 12 answered 3. Now, I could add up, I could say 1 plus 1 plus 1 plus 1 4 times, then add 2 plus 2 plus 2, and keep doing the 2 for 8 times, and then 3 12s, and then 4 6s, and then 3 5s, 6 4s, 2 6s, and 1 8. But there's a faster way I could do it. I could put all my 1s together and multiply them out. I've got 4 1s, so I got 4 slices right there. I have 8 kids that want 2 slices, so I have 16. 12 that want 3, that's 36. 6 that want 4, that's 24. And then just add them all up here. So I would need 115 slices for 36 kids, which means on average, if you divide those two, I need 3.19 slices per kid. All right, let's go ahead and do our deviations like we did before. And what I'm going to do is subtract this minus my average. So 3.19 is my x bar, my mean. So 1 minus 3.19 should give me a negative 2.19. and then 2, and then subtracting 3 minus 3.19, since it's lower, it's still negative. And you're going to see this pattern if these numbers are in order. You're going to start with negative values because you're below average. And then as you get higher, you eventually cross the average and get above it. Just like before, I'm going to go ahead and square, and those add up to 0, so that's good. I'm going to square all these numbers, just like we did in the last lesson. But do I just add all these numbers up? No, because I actually have four of these, 4 480s, and I have 8 142s and 12 0.04s. Now I could write down 480 plus 480 plus 480 plus 480, and then start going plus 142 plus 142 plus 1, you see the whole thing. Or I could take the same approach I did for this column and just multiply it by the frequency. So here is what I get when the products for the deviation squared times the frequency. Add them all up, and then if I divide this number by not exactly that number, remember, we're almost always using samples. So I'm going to divide this number by one lower than that. 83.64 divided by 36 minus 1 is 239. And the standard deviation is the square root of that number, or roughly 1.55. All right, now we're going to look at a histogram data. And this is for different age groups of people playing Pokemon. So, and I made the numbers up. So I had 10-year-olds to 19-year-olds playing Pokemon. And so what would be the next class? Well, I know I want to start after 19, so that means I'm going to do 20 to 29. I want the class widths to be the same for each category. And so we have 50 to 59. Mrs. Overman's down in here. All right, what are my class boundaries? Well, I go a half unit before the 10 and a half unit after the 19. So my class boundaries have to be a teensy bit bigger on each side so that this fits in that. Now, after that, it gets a little bit easier because I know this number is going to be the front one. And then I can use class width, which is 10 here. See, 10 to 20. It's not 9, it's 10. So it goes from one lower limit to the other. So I could go 10 here, so 19.5 to 29.5. And then add another 10 here, and here, and here. And so I have all my class boundaries. Now I have my frequencies. And I could do this trick right here where I'm going to multiply my frequencies times a number for my class limits. But should I use 10 or should I use 19? 10 is probably going to be too low. 19 is probably going to be too high. What would be a good compromise? The midpoints. So forgot to add my frequencies there. So my midpoints are 14.5, 24.5, and notice the difference is the class width again. And I find all my midpoints, and now I multiply them by all the frequencies. And I add them up, all right? If I'm trying to determine the mean, I'm going to take this number right here and divide it by that number. So I get 30.91 is the average. So the mean age of people playing Pokemon, based on my made-up data, is 31. But actually, we don't have that many 31 people. We got some old fogies like me and some young kids like you guys playing Pokemon as well. So let's go ahead and do the deviation. I'm also going to use the midpoint for that. So I'm going to do 14.5 minus 30.91, and then 24.5 minus 30.91. Like before, it always starts negative and then goes positive, if these are in order. All right, then I'm going to square them, just like we did before. Then I'm going to multiply each one of these by their frequencies, excuse me, and get this. Finally, I total it up on bottom. And if I want to find the variance, I want to divide this by that minus 1. So the variance is 16,473 divided by 64 minus 1, or 261.5. And then to take the standard deviation, I just take the square root of that, and I get 16.2. Now, here's a little side note. Sometimes you'll be asked to find the median for a histogram. So what you do is you total the frequencies, which is 64, and you divide by 2. So count through the frequencies until you get halfway through. Well, 64 divided by 2 is 32. So there's going to be 32 in the first half and exactly 32 in the second half, which means my median is going to be halfway between points 32 and 33. If I count through here, and always start counting at the lowest, go in order in one direction or the other. I usually start at the lowest, all right? So if I count all through all these points, there's 24. So I'm not quite halfway through. If I count through all these points here, I've passed the halfway mark. Both points 32 and 33 are in this group. So the 32nd and 33rd points are in here. So we'll use the midpoint, 24.5, as the median.